Chat is not chatting point. Yes. One is hmm? Network, huh? Network is no, not network. This trying to connect this. What is this? OneNote. Right. Okay, now okay. Yes. Yeah. Yes, right. Yes. Double switch. Excellent. Yes. Right. So, to understand this, you still need to have an idea about basic idea about the interference, superposition principle, and what is the intensity, and what is constructive interference, what is destructive interference conditions. Constructive superposition, destructive superposition. Superposition is nothing but interference. And then
Normally, we will use the notes on the clarity
this points are
transactions. Just glance.
actually in wave optics in the previous sessions discussed about some basic points like especially those are like wavefronts and all okay. But as part of this interference, to discuss about what is displacement equation or wave equation. Displacement of light wave or wave equation. Wave equation is represented as y is equal to a sin omega t plus phi naught. It is not only actually light wave in a mechanical way. Discuss in general any wave, mechanical wave. Okay. So where a represents amplitude of the wave and omega is frequency and phi naught is called initial phase at time t equal to 0 phase. Then total omega t plus phi naught will be called as phase angle or total phase of the given wave. Okay, and here A is amplitude. A is amplitude, and Y is the displacement of the particle of the medium when a wave is traveling. Okay, in, then this instead of we can also write this phi naught in terms of direction of propagation. We can also express this as a y equal to a sin omega t plus or minus kx. If this is traveling in the negative direction, we can write it as plus kx. In positive direction, minus kx. So where k is called a wave number.
So why is it like opposite to positive x direction and negative direction?
So usually a wave is if you consider a wave will be traveling in three-dimensional wave means it will travel in all directions. So for example, I'm talking now. So you can get my sound, my voice. Even you are sitting here in front of me or to my left, to my right. That means the sound wave will travel in all directions. So if you want to say specifically in particular direction, because there are different types of waves are there. In 11th standard, we have studied in waves, right? Progressive waves, standing waves. Again, what do you call longitudinal waves, transverse waves. So how we have classified them the waves if the particles of the medium are vibrating in the direction of propagation and if the wave required a medium for the propagation we can call it mechanical wave. In that if the particles vibrate in the direction of wave propagation, such kind of waves are called longitudinal waves. If the particles are vibrating in what particular direction to the direction of propagation, they are called as transverse waves. These points just will tell you in which direction it is propagating and which direction particles are vibrating. That is given by this. This is considered what you call progressive, the progressive mechanical wave. Whereas actually light waves will be treated as electromagnetic waves. They are observed to be electromagnetic waves, does not need any medium. So that we have to keep that also in point. And here electromagnetic waves when you say does not it does not need any medium. That means there will be no particles in the medium are vibrating. But then what this Y gives is when the electromagnetic wave or light wave is traveling, it is observed that it is a combination of electric and magnetic fields. Electric and magnetic fields will vibrate perpendicular to one another to the and also perpendicular to the direction of wave propagation. So that's why they are called as electromagnetic waves. Okay. So here this wave Y represents the direction of vibration of a given element. So we are not specifically mentioning that which is electrical or magnetic. Just what do you call displacement of the particle. Here we can say just by comparing with the mechanical wave, displacement of the wave is this displacement of the uh, particles of the medium, not wave. So here x represents displacement of the wave. X represents in which direction it is moving. So for example, x direction, how much distance it has traveled, or how much displacement it has traveled in x direction. That gives displacement of the wave. So displacement of the wave is different, displacement of the particle is different. That's why we will come across here in there itself mechanical waves. We will come across wave velocity, particle velocity. Wave velocity and particle velocity. So these points just you need to have an idea about. Now we will not worry about all these things. So yeah, here the light waves in terms of phase if you consider if one wave is having amplitude A1 and phase initial phase phi1 and another wave having amplitude A2 and initial phase phi2, and if these waves superpose, to determine the wave resultant wave, the amplitude of the result, the displacement of the resultant wave, how to get this? explained already. So in this, on simplifying, we get displacement of the resultant wave or resultant displacement of the wave combined wave is given by A sin omega t plus phi, where A is called as resultant amplitude or amplitude of resultant wave, and it is given by how to get this resultant amplitude is you can consider this as AR, resultant amplitude. It is given by here this is AR. You can take also consider this as AR, here AR, AR. So amplitude of the resultant wave is given by square of the amplitudes of individual waves, that is a1 square plus n square plus 2a1 a2 cos phi, where phi is the phase difference between the given waves. Phase difference. So that's why just here we are not worrying about the direction. We just have light waves. We'll discuss about the phase for light waves and the electromagnetic waves. So that means you can say amplitude of the resultant wave depends on the phase difference. If the phase difference phi is a particular value, amplitude will be maximum. If it is some particular value, it will be minimum. So that particular value of phase difference to which we will get amplitude maximum will be called as under that condition that a process of what you call mixing of waves will be called as what you call constructive interference. Constructive interference. The barrier, the phase difference for which you are getting minimum value of amplitude will be called as destructive interference. So it is observed and calculated actually those values of phi also. Here just I have not given those values. For getting maximum value of A, when you will get A from this maximum value of A, minimum value, I think we have discussed somewhere here. Yeah, constructive and destructive interferences. Here we have discussed. For constructive, when you will get constructive means maximum amplitude will get. When you will get maximum, then the cos it depends only on this for a given amplitudes of two waves. So if cos phi is maximum, then you will get maximum amplitude. When cos phi will be maximum, what will be the maximum value of cos phi plus 1? For what angles of this it will be plus 1 for a 0, 2 pi, 4 pi, and all these values it will be plus 1. That means you can write this as phi is equal to what is that? 2 into 2. Actually, if you observe 0, 2 pi, 4 pi, and so on, that means even multiples of pi. Even multiples of pi can be expressed as 2n into pi, where n is equal to 0, 1 to 3, and so on. Then we'll get 0, 2 pi, 4 pi, and etc. So for this values, we get constructive interference and hence maximum amplitude and hence maximum intensity also. Whereas intensity here can be expressed as here. The directly from this you cannot get this. Actually, if you can write it as a square, if you write this as a square is equal to, if you square on both sides, a square is equal to root will go off. A1 square plus a2 square plus 2a1 a2 cos phi, where a square can be expressed as I, or if it is a amplitude of resultant wave, this is intensity of resultant wave. So is equal to amplitude of the first wave, second wave, intensity of first wave, second wave. Square of amplitude is intensity. Square of amplitude of the second wave is intensity of the second wave. In plus 2 a1 a2. A1 a2 can be expressed as root a I1 into root I2 or root of I1 I2 into cos phi. Okay. So by using this, you can get the maximum amplitude and maximum intensity. Okay. Then destructive interference. When you will get destructive interference, then the corresponding amplitude is minimum. When it can be minimum, and from this, it is depending on the phase difference. When phase difference is minimum. So what will be the minimum value of this? Minus 1. For what value of phi you can get minus 1? We observe for cos pi you will get minus 1. 3 pi will get minus 1, 5 pi also will get minus 1. That means for odd multiples, 1, 3, 5 multiples of pi you get minus 1. So you can, in general, you can say for pi is equal to n plus 1 into pi, where n equal to 0, 1 to 3, and so on. You get cos value as minus 1, and hence minimum value of amplitude. So if you take this as cos phi is minus 1, you will get a minimum is equal to square root of a1 square plus a2 square minus 2a1 a2. Actually, plus 2a1 a2 into minus 1, that gives minus 2a1 a1. If it is in the form of a square plus b square minus 2ab form, so you can write it as a minus b whole square. So that square and root gets cancelled, you get a1 minus a2. Then that will be the minimum value of amplitude. Whereas the corresponding intensity can be expressed as here. If you observe, if you take it as a square is equal to a1 square plus a2 square minus 2a1 a2. You can write it as a1 minus a2 whole square. Here a minimum square equal to. So a minimum is I minimum. I minimum is equal to root I. A1 is root I1. A2 is root I2 whole square. That step I have not written here, but you have to understand. Okay, this is how we can write the amplitude and intensity for constructive and destructive interference. These points you have to remember and you have to apply here in what do you call Young's double slit experiment. And I have also discussed about the relation between phase difference and path difference by using this. This also you have to remember. Delta phi is equal to 2 pi by lambda into delta x. Phase difference. Here delta phi is phase difference.
We have to make a person complete relation process. So we have to coefficient of this is
Hmm. Hmm. Completely. That's all. From starting from collisions, where collision starts. From here, where so so if you remember this, y is equal to a sin omega t plus kx1. Here this entire represents total phase of this wave. If there are two, another wave is having same amplitude but different omega t plus kx2, omega omega same is frequency same, amplitude same, but this has traveled different distances. Yes, then this will change this k into x2. Then here this is phase of the first wave, this is phase of the second wave. Phase of the first wave we take it as phi 1, omega t plus kx1. Phase of second wave we take it as omega t plus kx2. Difference between these phases can be taken as delta phi. It is equal to phi 2 minus phi 1. Phi 2 minus phi 1. Phi 2 is this, phi 1 is this. This minus this is omega t minus omega t cancel. Kx2 minus kx1 will get. Kx2 minus kx1. As k is common, if you take this out, you can write it k into 2, x2 minus x1. But where k is nothing but 2 pi by lambda, we call it as wave number. Okay, if substitute that, we can write it as delta phi is equal to 2 pi by lambda into this is difference between x, you can write it as delta x. We call this as path difference. So phase difference is equal to 2 pi by lambda into path difference. Okay, this relation. Now this will be used here in understanding scientists will be silence just as levels of
And he likes games and we attended games.
yeah. So here instead X double slit experiment. X double slit experiment. Okay, to understand the interference of light. Okay, a scientist from Young has constructed uh, a setup. It consists of two slits. Okay, two slits S1 and S2. The light from a given source is taken and it is allowed to pass through this, so that both will have same frequency. And if you consider this is center of the slits, the distance between the slits is taken as small d, small d. And to when it is observed that the waves from here and waves from here they will interfere and it gives an interference pattern on this. That interference pattern is taken or catched on a screen by taking a screen. It is observed that it is considered that the screen is placed at a distance of capital D, and provided one condition should be satisfied here is that this relatively this D will be much more greater than small d, or small d will be very less than, much more less than capital D. This condition should obey here. Then it is observed that if you draw a line from the center of the slits onto the screen, we call it as center of the screen, you can represent this as O. If a wave from here comes here and if a wave from here comes, both will travel the same distance. So it will undergo constructive interference. Same path they will travel. So path difference will be zero here, and hence they will, of course, it doesn't mean that path difference is zero will get destructive. Path difference is zero, then we'll get constructive interference. So here you'll get constructive interference and you'll get a bright band. Like that, then it was observed that at some point here, if a wave comes here and a wave is coming here, then at different positions, they are meeting constructively at different positions, they are meeting destructively. And to understand that, if we consider one arbitrary point P, let us say at this point, the light from here, this slit S1 is coming and okay, reaching this screen here, whereas light from here it is coming and reaching the point over here. So it is observed that for the understanding purpose, if we consider a reference line drawn from here, a reference line drawn from here, it makes an angle theta with this middle line or a horizontal line. So now, by symmetry, if this distance is much more greater than this separation between the slits, this S1P, we can call this line as S1P, this line is S2P. These will be parallel to, we can call this as this OPQ, QP, the parallel to this, what do you call it, QP, so that this also makes same angle theta with horizontal, same angle. So it better let us not represent here so that it becomes look clumsy. Now, it is very clear that this one is reaching this point quickly because it is little above, because it is little low, it takes more distance to travel. It is, by observing this, we can understand that. But to clarify it, let us try to draw one perpendicular line from here. If we draw a perpendicular line, what info it gives is, from here onwards, the length of this path and length of this path will be same, but a wave traveling from S2 has to travel an extra path of this distance. That is what you can understand. That extra path distance can be obtained by measuring first S1P and S2P. The derivation we will do actually, but here we are not discussing that. From the derivation, we used to say S2P minus S1P gives that extra distance. We express it as delta x. We also call it as path this path minus this path length minus this path length gives us the difference between the paths. We call it as path difference, delta x. And by symmetry, here this distance, if we take it as delta x, by symmetry, this is 90, so this is also 90. This is theta. Angle between this line and the horizontal is theta, but angle, this is vertical and this is horizontal, this will be 90. So this angle will be total 90 minus theta will be this one. This will be 90 minus theta, this will be 90, then this angle will be theta by symmetry. This is D, and this is making an angle theta with this line, then and this is what you call 90 degrees. For this angle, this will act as opposite side and this side will act as adjacent side. So if you resolve this D, you can say this will be D cos theta and this will be D sin theta. So delta x here will be equal to D sin theta. D sin theta. This d sin theta, depending on this value of d sin theta, we can say the waves which are meeting here will give you constructive interference and destructive interference. So let us consider this is equation 1. For constructive interference, the waves from S1 and S2 should meet in such a way that already we have discussed it, right? The phase difference path, phase difference relation. Phase difference relation. By using that, here you can relate with path difference. That is one thing. The other thing is, here for smaller angles, because D is much more greater, means the angles will be very, very small. As a D, here you can say, because capital D is much more greater than small d, all this S1P, S2P and QP are parallel, and hence theta is very small. Because D much greater than small d, theta is very, 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 very small. So for smaller angles, we can say, this implies for smaller angles, for smaller, angles, you can say sin theta is approximately equal to theta, and tan theta is also approximately equal to theta, and cos theta is approximately equal to 1. Approximately equal to 1 cos theta. So it's approximation trigonometric ratios you have to remember. As sin theta is approximately equal to theta, tan theta is also approximately equal to theta. Can we say sin theta equal to cos theta? Sin theta equal to tan theta? So you can say sin theta equal to tan theta. So that implies sin theta will be equal to tan theta, and from this symmetry here you can say yeah, from the symmetry QPO or OPQ, if you take it as a right angle triangle, tan theta, this is theta, this is also theta, so this theta can be expressed as, if this distance of this point, where suppose if you are considering the fringes of forming either bright or dark, it can be taken as y. Okay, for nth fringe, if you consider nth fringe is forming here, then its distance can be taken as yn. So from OPQ triangle, again say tan theta equal to opposite side by adjacent side. Adjacent side is nothing but this distance. So you can take tan theta is equal to yn by capital D. So this we can take it as sin theta, and you can substitute it here. You can substitute this here. Okay, this is another equation you can let us say. But what now we want to understand here is, this is about what is this path difference and tan theta here. Next, if this path difference is equal to integral multiple of lambda, then we'll get constructive interference. If it is what you can call it as odd integral multiples of lambda by 2, you will get a destructive interference. How can you understand that is, that is another, again I have to just recollect back here, is that for constructive interference, phase difference should be equal to what? 2 pi by lambda into path difference. Sorry, this is the relation between phase difference and path difference. For constructive interference, delta phi, phase difference should be equal to integral multiple of pi. If you say, so for constructive interference, phase difference should be equal to n pi. Then what about path difference? You may ask, delta x. The relation between these two is delta phi equal to 2 pi by lambda into delta x. For constructive interference, delta phi should be equal to n pi. If you substitute this here, you will get delta x. So delta x is equal to delta phi into lambda by 2 pi you will get. This will, if it goes here, it becomes delta phi into lambda by 2 pi. For constructive interference, delta phi should be n pi. Substitute this here, n pi into lambda by 2 pi. Pi gets cancelled, we will get n into lambda by 2. So for constructive interference, path difference should be equal to n lambda by 2. That is where n is equal to 1, 2, oh sorry, what did you get here? N for constructive interference, lambda by 2 you got. Wait a second, 2 pi by lambda, right? Is this n pi? Is it 10 pi or 2 n pi? 2 n pi. It is not n pi. 2 n pi. 2 n pi. 2 n pi. So 2 also gets cancelled. 2 also gets cancelled. So you get delta x will be delta x path difference should be equal to n lambda, and n is equal to 1, 2, 3 and so on. That means for n 0 also you can say 0, 1, 2, 3 and so on. For n is equal to delta x equal to 0, delta x is equal to lambda, 2 lambda, 3 lambda. For all these lambdas you get constructive interference. Whereas for destructive interference, we know phase difference should be equal to 2n minus 1 into pi. It is the odd multiples of pi. So if n is equal to 1, you get 1 pi, 2, 3 pi, 3, 5 pi, like that you get. For n is equal to, here n is equal to 1, 2, 3 and so on. So this is for destructive interference, phase difference should be equal to this. Corresponding path difference can be expressed as delta x. From this is delta x is equal to delta phi into lambda by 2 pi. That reverses delta phi into lambda by 2 pi. So this is equal to delta phi is 2n minus 1 into pi into lambda by 2 pi. So this pi gets cancelled, then you will get 2n minus 1 into lambda by 2 you will get. So that means where n equal to takes 1, 2, 3 and so on. So if it is 1 lambda by 2 you get 2, 3 lambda by 2, 5 lambda by 2, like this odd multiples of lambda by 2 of path difference delta x is equal to, what is this? 2n minus 1 into lambda by 2 you will get destructive interference. That means minimum amplitudes and hence minimum intensity. So for destructive interference, this is the path difference condition. This will be the phase difference condition. For constructive interference, this will be the phase difference condition. What is this? 2n pi, not n pi. 2n pi. Phase difference should be 2n pi, and path difference should be n lambda. And what happens under these conditions is you will get maximum and minimum amplitudes and hence intensities. So if you say for constructive interference we are getting maximum amplitude and hence maximum intensity means, okay, where at what position will get is the question. At what position will get is the question. So by making use of this, you can say this path difference for constructive interference from this, what is this path difference? N lambda, and lambda. If you substitute this over there, now this for understanding purpose, I have given you this all this. Now after taking this equations 1 and 2, now as equation 3, you can say for constructive interference, this is in general for all. For constructive interference, here let us take separately. So for constructive interference, you can say as delta x path difference is equal to what? N lambda, integral difference and integral multiples of lambda. So, actually this path difference in double slit experiment is nothing but what? 2d sin theta, right? 2d sin theta. But delta x in double slit experiment is 2d sin theta, d sin theta, d sin theta, d sin theta. Delta x is d sin theta. Delta x is d sin theta. Okay, d sin theta. From this symmetry, sin theta is nothing but again tan theta, which is equal to yn by d, yn by d. So if you substitute this here, you can also say it is equal to small d into yn by capital D, where yn is position of nth fringe. Here for constructive, and take it as bright and the bright fringe. If you, because these two are delta axis, if you equate them, then you get, by equating them, then you can say this implies, you can write small d into yn of bright fringe. What is the position of nth bright fringe by capital D is equal to n lambda. From this you can write, this implies position of nth bright fringe is equal to n into capital D lambda by the small d comes to denominator. This gives the position of nth bright fringe, where n is equal to 1, 2, 3 and so on. First bright fringe, second bright fringe, third bright fringe. From where? From this, in the diagram, if you see from this central maximum, we call this point as central maximum point. Similarly, bright dark fringes, where this dark fringes will be obtained. Dark fringes will be obtained for destructive interference. For destructive, destructive interference. For destructive interference, we can say that what is phase difference condition for destructive interference? 2n minus 1 into phase difference. Path difference, we have obtained that delta x is equal to 2n minus 1 into lambda by 2. But remember immediately destructive means both path difference and phase difference conditions. Constructive difference, path differences and lambda, phase differences 2n pi. 2n pi. Similarly for destructive interference, phase differences 2n minus 1 into pi. If the path difference is 2n minus 1 into lambda by 2. Okay, so if this is one condition, but already in Young's double slit experiment we have obtained delta x is equal to what? D sin theta, and sin theta is equal to tan theta, and it is given as d into tan theta is position of that fringe by d. That fringe, if you take it as a destructive interference, what fringe will get? Dark fringe. So position of nth dark fringe by d will consider. So now if you equate these two, because delta x on left side part is are equal, you can write it as this implies d into position of nth dark fringe by capital D is equal to 2n minus 1 into lambda by 2. This, on simplifying further, you can write a position of nth dark fringe is equal to So this if you send capital D multiplies and small d will come to denominator, then you can get 2n minus 1 into capital D lambda by small d comes here, 2 is there, divided by 2d. So this gives you the position of nth dark fringe. Position of nth dark fringe. Okay. So by making use of these points, you can also understand one more point called fringe width. Fringe width. So if you are getting this at some points, so what you can understand here is from this bright fringe will be obtained at first bright fringe will be obtained at n is equal to 0 also. N equal to 0, you get first central bright fringe.
All the will be zero.
All them will become 0. That means from central fringe there itself will get center point where in the
So
diagram.
then bright fringe and dark fringe will be originating in the same point, and then only it will be.
Bright fringe will be first bright fringe will be obtained at center. When this waves comes here, equal distance they will travel. So they with zero phase difference they will mix up. They will interfere and it will bright fringe. They will undergo constructive interference means they will be bright fringe. But
Center bright fringe.
center always bright fringe. And beside this, you get dark. After bright, the next you get dark fringe. Then you get bright. Then again you get dark. How can you understand this? Is from this you can realize that. So you just let us try to write these expressions separately. Position of nth bright fringe and the position of nth dark fringe. And the dark fringe. And what? Position of nth bright fringe is what? N
Lambda,
lambda
capital
d lambda by n into d lambda by d. Capital D lambda by small d. N into d lambda by small d. N into for this one. N into d lambda by d. Bright fringe position. Length bright fringe. N into d lambda by d. D lambda by d. But capital first, small like next. Capital first, small next. So capital in numerator, small in denominator. So n into d lambda by d. D lambda by d. D lambda by d. Okay. First d is capital, second is small. So here n is equal to 1 to 3 and so on. N is equal to 0, 1 to 3. For bright fringe, you have to carefully and remember n is equal to 0, 1, 2, 3, and so on. For 0, you will get central bright fringe. Here you have to write that for n equal to 0, we get central bright fringe. Central bright fringe. Okay. Whereas then we will get the another secondary bright fringes. Central then secondary bright fringes. Then similarly, position of nth dark fringe is given by position of nth dark fringe is given by 2n minus 1 into d lambda by d, where numerator d will be capital always. Okay. Then here also, because I have taken minus, I will take starting from 1. Okay. N is equal to 1, 2, 3, and so on and so on. So we'll get first dark fringe is at d by lambda, d by 2d, right? 2d. D lambda by 2d, then the 3d lambda by 2d, and so on. We get this. And here, if you observe, first central bright fringe at n equal to 0. Hmm? So n is equal to 0, we'll get what is that central bright fringe? Central bright. Central bright. If you want to understand this a little more deeply, just I'm giving this extra additional explanation. Okay. If n is equal to bright fringes we are talking about. For n is equal to 1, we get first bright fringe. This is central bright fringe, then first bright fringe. The position of that is given by y1 is equal to what is that? Y1b or yb1 or whatever, anything you can take. Yb1 first bright fringe is what? D lambda by d. And n is equal to 2. Yb2 second bright fringe is 2d lambda by d, and so on you get. Right? But if you observe here, dark fringes beside only. Dark fringes are given by this. N is equal to 1, you get first dark fringe. So n equal to 1 means 2 minus 1 is 1. So first dark fringe is given by how much? D lambda by 2d. Means if you have the second dark fringe will be obtained at y d2 is equal to 4 minus 1 is 3d lambda by 2d. What you can understand from this is first bright will be obtained at d lambda by d. If you take this is 1 unit 1, this is 1, d lambda by d is 1, then it will become 1 by 2 distance dark fringe will get. What does it mean?
From the
If this is the bright fringe, from here at 1 unit, this is 1, at 1 unit if you are getting bright fringe, next bright fringe means at 1 by 2 you are getting dark fringe, means here at half you are getting dark. Similarly here also this side also at half you will get dark, then at 1 you will get bright fringe. Then next bright fringe will be applied at 2d lambda by d. Means if you take it as 1, this will be 2. This is 1, then this will be your 2. Here again you will get bright fringe. But next dark fringe will be at where? 3d lambda by 2d. That means 3 by 2 is 1.5. 1.5 d lambda by d. D lambda by d is 1. 1.5. This is 1. It is 2 means 1.5 comes here, right? 1.5. 1.5. 1.5. Yes or no? Is 0.5. 1. 1.5. 2. So here we get text dark fringe. That means first central bright you will get, then next dark at 0.5, then bright, then dark, then bright. That is what you can understand. They will be obtained. They will be obtained in this way. This is how we can understand the location of these fringes. Okay, so that is just cannot give all these things in the class. So these are some basic points. So this is some additional information. You guys have to understand this. It will deeply if you go. So accordingly, if you observe now, first bright fringe is this, second bright fringe is this, first dark fringe is this, second dark fringe is this. So from or with respect to the central bright fringe, if you consider not the central bright fringe, any two bright fringes. This is one bright fringe, this is another bright fringe. The distance between two successive bright fringes or two successive dark fringes gives us fringe width. That means if this is bright means from here to here you will get somewhere here you will get a bright only. Got it? Somewhere here the dark band you will obtain. These are not lines, they are bands. So further how can you understand this is you will get a bright fringe, bright band here, then dark, then this is bright, central bright, then dark you will get here also one dark, then one more bright here, one more bright. So that means this is bright, central bright, then dark, then bright, again dark will come here. So here distance between any two successive bright fringes means from the starting point of bright to the starting point of bright, or here to here, ending to here, or this to this. This will give, or this is bright fringe. This is the next bright fringe starting. So distance between these two.
between these two are distance.
Actually speaking, the distance between the centers of centers of the bright fringes gives you what you call the fringe width.
So the dark will become
Similarly, dark fringes also, if you want, centers of dark fringes will give you fringe width. So this will be defined as the distance between any successive bright or dark fringes, and it is called as fringe width. Fringe width. It is denoted by fringes or bands anybody can use. Fringes. Distance between any two successive. Use the word better successive. Distance between any two successive. What is this meaning of successive is? Say here, if you consider any two bright fringes means this bright, this is central bright, next bright you will come across one more bright here. The distance between this, not this bright and this bright. Successive. This bright is the next bright only. That is the meaning of successive. Distance between any two successive bright fringes and any two successive dark fringes is called fringe width. Is called what? Fringe width. The distance between any two successive bright or dark fringes is called fringe width. Is called fringe width. and it is denoted by beta. So how can you then get the how can you calculate the fringe width mathematically? Is position of the first bright fringe is this, second bright fringe is this. Likewise, you can guess you can position of nth position of nth bright fringe is given by what is this? N into d lambda by d. D lambda by d, capital D by d. Okay, n into d lambda by d is position of nth bright fringe. So, or you can say here while representing this, you can say position of nth bright fringe, but nth bright fringe. Whereas the nth bright fringe, just before that, if a fourth bright fringe is somewhere, before that comes third one, right? Similarly, before nth fringe, you get n minus one fringe. So you can write in general position of bright fringe, which is n minus 1. N minus 1th bright fringe is given by n minus 1 into d lambda by d. Position of n minus 1th bright fringe. So the distance between this gives the fringe width, right? So by definition, beta is equal to, that means, say for example, if you are having, this is a reference point, here is your n. So here is your n, so that distance from here to here is yn, and here is the next n minus 1 fringe. So here from here to here, so from here to here is yn, from here to here is yn minus 1. Then if you want this distance from this entire yn, you have to subtract this, right? Then we'll get this one. This is nothing but your beta actually. So how can you do this? Is beta is equal to yn minus 1. This gives us what? This minus this, n into d lambda by d minus n minus 1 into d lambda by d. If we expand this, it is n minus 1, right? N into d lambda minus 1 into d lambda. Here again minus is there. If we simplify this, we'll get n into d lambda by d minus n into d lambda by d, minus of minus plus 1 plus 1 into just d lambda by d. These two will get cancelled. So therefore we will get d lambda by d. So this is called as fringe width. Fringe width beta is equal to just d lambda by d. Capital D lambda by small d. This is called fringe width. Where capital D is distance between slits and screen. Lambda is wavelength of the light we are using, and d, small d, is the separation between slits. Separation between the slits in this.
In the problem, so the equated the beta and theta, so whether both are who can they easily quotient?
Beta and theta.
So theta is equal to beta angle may be the
If the conditions is mentioned like that, say something like this.
theoretically.
So it's say different conditions. If usually if capital D should be much greater than small d for sustained interference should be taken place. Distance between the slits and screen should be much more greater than the separation between the slits. If not, you cannot observe. And separation between the slits will be very small, and wavelength that will be at the order of millimeters, whereas wavelength of the light should be at the order of nanometers. In some cases, it may be given. If the separation between the slits is of the order of wavelength, then what happens? This kind of questions will happen. In such case, if beta equal to theta, so numerically, if they are given, then based on that, the question will be given. So we have to work out based on the given data and conditions. Okay. So this is briefly about this. Okay. Anything else? We have to show.
Has to be online test.
I don't think it's there in the WhatsApp, right? In the WhatsApp group, I am sending the messages. So that is my number. So yeah. So what is that question number? 51. Question number 51. Way up. Page number 181. Page number 181. So what is the question? The convex lens of focal length 0.15 meter is made of refractive index 3 by 2. Is made of refractive index 3 by 2. When it is placed in liquid, its focal length increases by 0.225 meter, increases by this much. Then the refractive index of the liquid is refractive index of the liquid is What is mentioned here? The convex lens of focal length 0.15 meter is made of refractive index. This that is placed in a liquid, its focal length decreases by this new focal length increases. So let us consider if we have a lens in normal air medium, okay, and in this, if the lens is in air medium, its focal length is f. F is given as 0.15 meters or centimeters, meters or meters, and it is having the refractive index of the material of the lens. We can say glass, something like, for example, is equal to 3 by 2 or 1.5. Whereas if this lens is kept in a liquid, this lens is kept in a liquid, then focal length changes to f dash, which is equal to,
So we have to add up to this one for 0.15, we have to take this
that's all.
separate.
When it's placed in liquid, its focal length increases by this much. Increases by this much means all the existing value plus this. And which focal length changes to this means is different. Increases by this much means this plus this you have to take. So 0.375, 0.375, and what you have to take is increased by this means. You take it as
F plus
0.15 plus 0.225 is equal to 0.375 centimeters. And the refractive of the liquid is given. You're asked to find then what is the refractive index of the liquid is a question. So to deal with this, we have to use the lens maker's formula. Okay, from lens maker's formula, we know 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2, where r1 r2 are refractive radial curvature of the both surfaces. So the lens which is in air and the lens which is in liquid, both are same, so radial curvature will be same. So here, but when it is in air medium, the refractive index of the glass with respect to air we have to take. This is the equation 1. So focal length is this medium. Whereas in a liquid, its focal length becomes f dash. 1 by f dash is equal to, then when it is in a liquid, refractive lens is surrounded by liquid, not air. So then you can write the refractive index of glass with respect to surrounding medium will be liquid medium minus 1 into 1 by r1 minus 1 by r2. So let us say this is equation number 2. So here f and f dash are given, r1 r2 are not given, mu g and mu l are given. Then how to find mu l is not given, mu g is given. How do you find what is mu l? You are asking to find. So if you divide this, what you can say 1 by 2 gives 1 by f by 1 by f dash gives you 1 by f by 1 by f dash gives you f dash goes to numerator, f dash by f is equal to, this becomes mu g minus 1 divided by, this is mu gl means we can write it as mu g by mu l minus 1, okay, into 1 by r1 minus 1 by r1 2 by 1 by r1 minus 1 by r2, this gets cancelled, okay, then you will get
R2 will be minus R2 or R2.
whatever it is, both will have same value. Convex lens, right? Convex lens. First surface, second surface. But first surface will be positive, second surface will be negative. Okay, so for both, whether it is in air medium or liquid medium. So whatever, if the values are given, even though here in this kind of case, no need to worry about the values. So they will cancel out. 1 by r1 minus equal to yeah, 0.5 divided by let us write that, okay, mu g by mu l minus 1. Now let's simplify this. 25 2s 25 4s 25 7s are 25 sevens, right? 25, how many times 100 goes? 4. So how many times it goes? 25 threes, 6 times, huh? 4 plus 2, 6, yeah, 6 times. Then here it will be 12 plus 3, 15 times. 15 times. So again, 3 2s, 3 5s, correct? So 5.1s, right? So 1 by 2 is equal to So plus 1 by 2 is equal to 0.1 divided by mu g by mu l minus 1. Cross multiply, then you will get mu g by mu l minus 1 is equal to 1 into 2 becomes this 2 multiplies becomes 0.2. So from this we can write mu g by mu l is equal to plus 1. So it is 1.2. So this further you can write it as mu l you want, right? Mu l if you bring here 1.2 comes here. 3 this is mu g is 1.51. 1.5 by 1.2, 15 by 12, 3 5s by 3 fours, 5 by 4. Any option is not 5 by 4.
So this will test this.
Which one?
This one.
53. See tomorrow.